Hello guys, welcome to your channel which is SciEngineers. We have been uploading videos for the preparation for the engineering entrances, and this particular video is on the topic of oscillations, which is for your physics. So those who are new to the channel, you can just go through our playlist for the Mhtcet mathematics section, and we also have been uploading videos for the Mhtcet physics section. Thank you guys for subscribing to our channel and also sharing our videos, and also commenting on the videos on what more content you would like us to make on. So keep watching and keep learning, and happy learning. Stay safe in the current scenario. So let's get to it. In the earlier video, we had given you these two sums which were related to your topic of rotational motion. So this is the solution which we are going to be providing over here. So we have the ring of mass m, and the radius r is rotating about its axis, and the angular velocity is omega. Now two bodies which are attached to it, which is of mass m, are attached at the ends of the diameter of the ring. What is the kinetic energy loss? So for this, we need to first of all understand what is going to be the moment of inertia of the initial moment of inertia and the final moment of inertia. Now this type of sum we have already dealt with in the earlier video, so we will be just going quickly through it. So we have the initial moment of inertia I1, that is for the ring, which is equal to mr square, and we have the new kinetic we have the new moment of inertia, which is I2, which is along with this mr square. We have the two masses which are attached to it, which is 2mr square. Now we are going to be using the concept of conservation of momentum. So that is nothing but I1 omega 1 is equal to I2 omega 2. So from there we will be getting the new angular velocity. So that omega dash, if you just calculate using the same concept which we had used in the earlier video, we'll be getting this as m omega. So it's going to be capital M of omega upon m plus 2m. So this is the new omega which we are getting. Now I need to find what is the kinetic energy loss. So kinetic energy loss is nothing but the initial kinetic energy minus the final kinetic energy which is there. So the initial kinetic energy is nothing but half I omega square. So that is half I1 omega square minus half I2 omega square. So let's just do that calculation. So delta KE is nothing but equal to, because we are calculating loss, it's the initial minus the final. So that is going to be nothing but equal to half mr square omega square minus it's half the moment of inertia, which is, so we are taking this as m plus 2 small m's r square into the new omega. So the new omega we have calculated over here. So it's going to be the capital M square divided by m plus 2m the whole square into omega square. So this term gets cancelled out, and now we need to just calculate this thing. So in this we are just taking the half common, the m common, the r square common, and the omega square common. So inside the bracket we'll be having this as 1 minus m upon m plus 2m, that is small 2m. So if you just calculate this thing, what you will be seeing is that it is going to be equal to nothing but b. Moving ahead to the next one, we have a solid sphere which is rolling down a smooth inclined plane which is at height h, and it starts from rest. The sphere is starting from rest. Then what is the speed of the sphere? So we know that we have to use over here the concept of total kinetic energy. Total kinetic energy is nothing but the translation plus the rotational part. And what it basically is telling that the sphere is initially at this point, so it is going to be having the potential energy at this point. So that is mgh, because this height is h. And I need to find when it is coming at this point, what is going to be the kinetic energy of the particular sphere. So I'm going to be equating the potential energy, that is mgh, is equal to the total kinetic energy, which is nothing but equal to, we know it is half m v square into 1 plus I by mr square. So this I by mr square, because we know that for the sphere it is nothing but equal to 2 by 5 mr square. So the mr square gets cancelled out and this becomes half mv square into 1 plus 2 by 5. So this calculation leads to the answer, which is 7 by 5 mv square into 2, that is, this is going to be 10, so 7 by 10 mv square, and this is equal to mgh. So you can see m gets cancelled out, and from this we need to find what is the v. So v is nothing but root of 10 by 7 gh, which is nothing but your option B. So this particular question you can see is talking about two SHMs which are having two different time periods, and we need to find what is going to be the combination of these two SHMs if they are going in the same direction. There is a simple formula for this which you can remember. It's nothing but T1 into T2 upon root of T1 square plus T2 square, where T1 and T2 are nothing but the time period. So this is only when you have a time period which is given to you, time period of two different SHMs. So we have T1 which is 3 and T2 which is 4. So it is 3 into 4 divided by, this is nothing but 3 square plus 4 square, which is 9 plus 16, which is 25, so that's 5. So it's nothing but 12 by 5, and 12 by 5, you know, it's nothing but 2.4. So that's nothing but option C. Next we have the question which is the potential energy of a particle and the mass is given, that is 2 kgs. Now they have given lot of information to just basically confuse you. Only thing which is important if you just observe is that is the mechanical energy which is given as 36 joules and the mass which is 2 kgs, because the only thing which we need is the maximum speed. So when so you know that in SHM basically the kinetic energy and the potential energy are basically increasing and decreasing, but the total energy is always same. That is nothing but the mechanical energy is always same. So to find the maximum speed, so at one point the kinetic energy is going to be maximum and potential energy is going to be 0. So that's why we will be having the term that is your half mv square is equal to the mechanical energy, which is 36. Now the mass is given as 2 kg, so we can just substitute mass as 2. So the 2 gets cancelled out and we get v square is equal to 36. That means my option is C, that is the maximum speed is 6. So in the next question we have an SHM which is of 16-second time period, and I need to find what is its amplitude going to be. The information which is given to us is that is at time t is equal to 2 seconds the particle is crossing the mean position, and at time t is equal to 4 seconds the velocity is 4 meter per second. So let us assume that the equation of the SHM is x is equal to a sine omega t plus phi. So I need to find what is phi. So phi can be found out when we have the mean position which is given, that is the mean position is at time t is equal to 2. So if I substitute 2, the mean position is 0. So that is equal to a sine 2 omega plus phi. Now here we know omega is nothing but 2 pi by t. So the time period is given to us as 16. So it's nothing but pi by 8. So from this we'll be getting the phi value. That means basically my sine is 0. That means this angle is going to be 0. So from this I'll be getting my phi as minus 2 omega, and omega we have found it is pi by 8. So this becomes minus pi by 4. So we have found what is your phi. So you can just substitute in x. So x becomes a sine omega t. So omega we can just substitute, that is pi by 8 t minus pi by 4. Now they are talking about the velocity which is 4 meter per second at time 4. So we can just differentiate this x so that we get the equation of velocity. So if I differentiate, I will be getting the velocity as a pi by 8. This is going to be cos pi by 8 t minus pi by 4. Now the velocity is given to us as 4 and the time is given to us as 4. So I'll be substituting this. So this becomes pi by 2 if I substitute 4. So it's pi by 2 minus pi by 4, which becomes pi by 4. So this is cos pi by 4. So from this I will be getting A as 4 into 8 into root 2 divided by pi, which you calculate, you will be getting the answer as D, which is 32 root 2 by pi. Let's move on to the next one. We have the displacement of the object, which is given by this equation, and I need to find the time at which the speed is going to be the maximum at the first instant. So the equation x is given, so we can just differentiate this so that we get the velocity equation. So I'll be getting the velocity equation as 2 into 10 raised to minus 2 pi with a minus sign because cos is minus sign, so sine pi t. Now I need to find the velocity is going to be maximum, so for that I need to differentiate this again with respect to time. So I will be getting dv by dt, which is basically acceleration, but I need to find maximum, so let's just write it as dv by dt. It's going to be 2 into 10 raised to minus 2 pi square cos pi t. Now I need to make the velocity as maximum, that means the derivative of it should be 0. So if I'm equated to 0, that means cos pi t is 0. We know that cos pi t becomes 0 when it is pi by 2. So pi t will become pi by 2. And pi gets cancelled out, so t becomes half. That means the time should be 0.5. So as you all know, we have this particular segment where we give you practice problems. So these are your 2 practice problems for this particular video. The solution for this will be posted in the upcoming video. So thank you guys for watching our video. This was your topic on oscillation. We'll be making one more video on this particular topic. Do write in the comment section what more videos you would like us to make on. Your suggestions in the comment section will help us determine what next topic should be. Do like our videos, do share our videos, and to subscribe to our channel. Don't miss to hit the bell icon, which is just beside the subscribe button. So keep watching and keep learning from our videos, and happy learning and stay safe.